I will be doing video number 10A. A semi-truck is driving along the x-axis, a van along the y-axis, and a car 45 degrees from the x-axis, as shown in the figure. The three vehicles all collide at the same time and stick together. What is the velocity, magnitude, and direction of the three cars together as one immediately after the collision, so that you can ignore friction of the cars after the collision? Okay, so we pretty much have this diagram of three vehicles, a truck, a van, and a car colliding at this point. And after the collision, immediately after the collision, they all stick together. So I'm assuming this collision is inelastic. And so we want to find the velocity, the magnitude, and direction of the velocity. Okay, so we can find the magnitude first. For the magnitude, since there are two components here, there's the x component and the y component of the velocity. So we would have to split our momentum equations into x components and y components. So first, for the x component, we know that the truck is traveling in the horizontal direction along the x-axis at a velocity of 15 meters per second, and its mass is 6,000. So you would plug in mass times velocity of the truck in the x direction, which would be 6,000 kilograms times 15 meters per second going along the x-axis. Then you got the van. The van has a mass of 2,000 kilograms, and it's traveling 0 meters per second along the x-axis. It only has velocity along the y-axis, which is 15 meters per second going downward. And then you have the car, which is 45 degrees from the x-axis, and it has x and y components. It is 45 degrees from the x-axis here, and using geometry, we can find out that's equivalent to 45 degrees here from this triangle. And so we want the x-axis component of the velocity of this car, which is cosine. So you would do 20 meters per second cosine of 45 for the velocity in the x component, and the mass is 1,500 kilograms. So you'd plug that in, and that would all equal the total mass, because all the vehicles are combined together after the collision, which would be 9,500 times the final velocity in x direction, and you get 11.71 meters per second. And now we want the y component. It is the same exact equation, except using y components. So you want mass times velocity of the truck in the y direction plus mass times velocity of the van in the y direction plus mass times velocity of the car in the y direction equals the total mass times the final velocity in the y direction. Okay, so the mass is obviously still the same. It'd be 6,000 kilograms. But for the truck, it doesn't have a velocity in the y direction. It is only horizontal at 15 meters per second squared. So therefore, the y component for velocity would be 0. The van, however, has a velocity of 15 meters per second along the y-axis. So it would be 2,000 times 15. For the car, you would want to use the y component of the velocity, which would be sine of theta, sine of 45 degrees. So that would be 20 meters per second times the sine of 45 degrees. And you'd plug that in times the mass, which is 1,500 kilograms. And you'd make that equal to the total mass times the final velocity in the y direction. And you solve it, and you'll get 5.39 meters per second squared. Now, you have the x and the y component of the velocity. And to find the magnitude of the velocity of the final, you would have to the square root of velocity final in the x direction squared plus velocity final in the y direction squared. And so you do that, and you're left with 12.89 meters per second squared. So that is the magnitude of the velocity of the cars after the collision. Now, it also wants us to find the direction. So we can use the x and y components that we found here to find the direction. We know that tan is sine over cosine, so tan of theta, it would be y over x, because y is sine and x is cosine. So that'll be sine over cosine, y over x. The y component, we found out to be 5.39 meters per second squared. the x component we found out to be 11.71 meters per second squared. So you would put that over each other, and then you solve for theta. You would do theta is equal to tan inverse of 5.39 over 11.7, and you would get theta is equal to 24.72 degrees to the right, and that would be the direction. So this would be 24.72 degrees above the horizontal and to the right, with a magnitude of 12.89 meters per second. And so that is the answer, and this relates to what we've been learning in class recently, because we've been talking about momentum, inelastic, and elastic collisions. Thank you.